Number 13 gives you an inequality. Negative x plus 2y is less than or equal to 13. And then you're given a coordinate pair and asked to tell whether the coordinate pair is a solution of the inequality. Emphasis, show your work. So what we're going to do is take this inequality, we'll use it for both parts A and B, and we're going to change the x and y to whatever is told in the coordinate pair. So I'm going to rewrite the inequality, but instead of x and y, I'm going to put some blank parentheses. All the numbers and symbols and signs stay the same. In place of the x, we're going to put a 5, and in place of the y, a negative 2. Now at this point, you can take this whole left side and calculator it out. You would be left with negative 5 plus negative 4, which is negative 9, is less than or equal to 13. And then all you have to do is decide if that's a true statement or not. Negative 9 is in fact less than or equal to 13, so yes, this is a solution to the inequality. We'll do the same thing for part B, except now we'll change x to negative 1 and y to 6. So again, copy down the same inequality, change the letters to blank parentheses, and in place of x, negative 1, in place of y, 6. You can calculator this. What you'll end up with is 13 is less than or equal to 13. Again, this can all be entered into the calculator in one shot. This is also a true statement since 13 is equal to 13, so your answer for part B would be yes. Numbers 14 and 15 ask us to graph an inequality. Remember that these things graph just like lines. Sometimes the line is dashed if you had a greater than or less than, but because this symbol includes the equal than part, this line will be solid. So typically to graph the line 1/2 x plus 3, we would put a dot at the y-intercept, which is positive 3, and then we would count the slope, which is 1/2. Up 1, right 2. We said earlier it's a solid line that goes through those 2 points, and because y is greater than or equal to, we're going to shade the area above the line. Number 15, same deal. We graph it as if we're graphing a line. Starts with an intercept of y equals negative 2, and the slope is negative 2 over 5. So down 2, right 5. Again, it's a solid line because it's a less than or equal to. If it were just plain less than, it would be a dashed line. And because it's a less than symbol, we're coloring below the line. Okay, don't forget to shade above or below the line. Number 16 asks us to graph the inequality y equals negative absolute value of x. To do this, you need to make an xy table. Remember, the x value of the vertex is whatever makes 0 inside the parenthesis. So in this case, x would have to be 0 to have a 0. The y part of the vertex is typically tacked onto the end, but in this case there's nothing there, so it is also a 0. So we know that the vertex of this graph will be at the center, 0, 0. We're going to have to fill in the table for x values on either side of 0. So first we'll say negative absolute value of negative 2. I changed x to negative 2. So the absolute value of negative 2 is positive 2, and then if we bring down the negative sign, it makes it negative 2 again. The absolute value of negative 1 is 1, and when you bring down the negative sign, it makes it negative 1. So if x is negative 1, y is negative 1. The absolute value of 1 is 1. So if we bring down the negative, it makes it negative 1. And the absolute value of 2 is 2. So if you bring down the negative, negative 2. All we have to do the rest of the way is graph all of these points. Negative 2, over 2, down 2. Negative 1, over 1, down 1. We already graphed 0, 0. The next point is at 1, negative 1. And the last point is at 2, negative 2. Notice how it makes a nice V. Your graph should always make a nice V, and you draw the lines through it. You can skip number 17. It's a bonus if you try it. You'll get some more points the more you do correctly, but you don't have to do number 17.